determine if the ponds are meeting their lifespan, if they're having problems with leakage or maintenance on them. What they're hoping to get out of that is to find out whether there's a lot of problem lagoons out there that need to be focused in on for cost share or to remodel or redo the lagoons. We've had a few that have had problems in the recent past, with one failing down in Snohomish County and a couple of others with leaks that came to the attention of NRCS. So as those things come through, some of it's maintenance, some of it is just old ponds built to old standards in ecology, not wanting to accept the old standard and wanting to push for better and better practices on the ground. Groundwater nitrates is one of the issues that come to light on that, and then having enough storage so you don't have to be applying your manure in a risky time is another part of it. This is a barely you can see as-built. This is a hand-drawn, what we find in their files when we look at your pond. What we're doing is putting together a spreadsheet that goes into your farm plan. A lot of the as-built, this was a 1990 pond that was built, the 250 by 220, 14-foot depth. The side slopes, they average out to 2.75. Put it into our spreadsheet as part of your farm plan to come up with that storage volume. That storage volume it starts out the gross volume, but then we take off the top foot and bottom foot for dead storage and for the freeboard. You're not supposed to operate within the top foot, plus the storm, 25-year storm event, which in this case is 3.7 inches. So it calculates in the volume of that storage structure. And also on the farm plan, we put an application schedule just to try to double check that you can make it through the non-application season. One of the things within the side slope criteria for NRCS, the combination of the side slopes have to add up to 5 to 1 to meet their standard. And that's been part of their standard since it started 87. The 5 to 1 is 2 to 1 as a minimum on the inside and 3 to 1 on the outside. It could be 2.5 to 1 on the inside or less, and then you could have 2.5 on the outside. But the 5 to 1 is to have structural stability on the bottom of the pond so it doesn't leak through, but also so it doesn't tip over or blow out. There's ways to get to steeper slopes, and a lot of times we see where ponds have been cleaned out and they'll have a steeper slope on the inside, and that's a problem because of stability. It'll erode down, but also for safety. If you ever had to crawl out of there, it's hard to get out of this. The way to get back to the NRCS standard, though, is to add to either the back side of that lagoon, because again, this blue line would be the standard that would be acceptable. If you don't have this standard footprint, NRCS isn't going to accept that as a pond. So if you go in and excavate out that liner could be breached, so there's issues with liner material too. But in the old ponds, there weren't liners actually before 1994. The liners that were used in that time period were just the earth liner that was available, compacted and placed. There's a 2 to 1 slope, so 2 to 1 slope is tough to actually put clay on and get it compacted, but it's been done. And it's one of those that the construction equipment, timing of the placement, and then the roller, it actually is where we have to get this tested. So if that roller doesn't get compaction on it, then it has to be done again to get high enough compaction to meet the test for today's standard. Again, previously to the liner standard, they were dug in place, and so it wasn't as critical for that machinery to get on there. So a lot of the older ponds do have steeper sides. The freeboard, again, is the top foot plus the 25-year storm event, which is 3.7 inches in Linden, and I think Acme is 3.7 inches. Dead storage is at the bottom foot. And we don't use that in that calculation of storage for your pond. So when we're talking about your gross storage for your lagoon, we take that off inside of your farm plan calculation. A lot of farms with 3 or 4 lagoons or double, the secondary lagoon, you're not getting as much solids in that second one. So that dead storage, you might not get a foot of loss out of it because there's not as much solids making it there. Separators, other technologies can help with that as well. But the top foot, what's critical is you don't get water all the way to the top, because a lot of times we'll have saturated condition just due to the rain. And when you get that saturated conditions, you can actually get water going over the top. Within the grass, you won't see it, but when you walk on it, you know it's soggy and it's pretty unstable. I've walked on a lot of lagoons that were all the way to the top, and even some that were running over that didn't blow out. So it's not something that is ultimately going to always fail, but the safety factor of that 1 foot keeps that top foot dry. And a lot of times there'll be mole holes or worm holes or other things that will actually leak out as well, and even wick out as that pond comes up to that top foot. It'll come up through that wormhole, and you won't even see it on top, and it'll be coming out at the bottom. You don't know where the water's coming from, and it's a scary situation. This shows a depth marker, which is not required anywhere in the standard, except as a marker for complete full level. And that is one that a lot of times has not been maintained or even installed in some cases. But that was to indicate where your pond was hitting that maximum fill mark. And that is for you to know when to start emptying it according to the standard. But in our case, we know that we have multiple storage cells, or that maybe it never hits that mark because it never gets all the way full. But again, to know if we're getting into that freeboard. This is a foot by foot, talking about the bottom foot's usually, or is, less than the top foot. In this case, it was a small pond, but it was a 1.5 million gallon pond. That the bottom foot was 150,000, the top foot's 250,000. So the difference in that top and bottom foot is substantial. In that top foot, again, is that freeboard that we're not taking into account when we're doing your calculation for storage volume for your farm. Again, the adding up these other feet is the design volume. O&M practice specifications in your farm plan, and that is where it talks about everything you're supposed to do on a regular basis to maintain that storage structure. The analogy is that storage structure is just like a tractor. You need to do maintenance on it to keep it up to speed, and it may have only cost $5,000 or $10,000 to put in 10 years ago, but now it's a $100,000 value out there. If it's functioning properly, with good maintenance, it can last another, it's a 20-year lifespan on our design standard. A lot of these pieces I'll go through, but the repair and replace and check for rodent is all pieces that you want to look at. The maintaining vegetation on the outside of the bank is so that you have protection so it doesn't erode, but that grass can actually grow up too high and you won't see the rodent holes. So it's one thing that we need to keep maintained, at least at a level that you can do your inspection to see if it's got problems. This is a brand new lagoon, but the point here was the grass on top. It's a small erosion control, or a slow growing short variety of an erosion control grass. It stays short so you don't have to mow it as frequently. This is one where they're able to mow or harvest up to the lagoon bank, and that's one way to keep the grass down as well. This is one with mowed bank, even in the summertime with corn. One of the reasons to keep it mowed and to visually inspect whether it's been settling. We have a lot of ponds that were built with variable material where they might have gotten a load or number of yards from a dump site that settles differently than the rest of the pond, and that becomes a low spot where it may overtop or have problems with Sometimes it's where the pumping stations are, where you put your pump and it's vibrated a little bit more, or you've had spills and things have soaked out. So to keep maintenance on that and understand where those low spots are and have that understanding of when the pond is full, you're supposed to be 1 foot below that lowest spot. So maintenance of the lagoon includes going back and filling that low spot in. But to fill that low spot in, you need to remove the sod so that you get a good soil contact with anything you add to it, and bring that back up to the elevation that we had when we started with that pond. Vegetation on the edges of a pond, and we had a lot of ponds that were built next to streams or ditches that do not get maintained as well as they could or should, and part of it is it's difficult to get down here and mow this because of the safety factor. So having an understanding of where this is going to go, if there is molehills down here, is into that ditch, and that becomes an issue. Another picture of a lot of vegetation that when those trees grow up and have roots that grow into the bank of these lagoons, whether that tree gets blown over or cut down, when it rots out, that'll be a pathway for the manure to go down. So to keep that managed before it gets out of control. Again, excessive weeds on the bank, and not having walked, or I have walked through these kind of lagoon banks where you can't tell if there's a problem or not, and that becomes an issue when things are looking bad on the outside of them. Overgrazed lagoon banks, we end up using animals to graze them, and which is fine, but again, trying to keep 3 inches is the minimum height for pastures, and we'd like to see that on the lagoon bank as well. This time of year, removing them to keep that grass growing this time of year. So it's been so dry, nothing's been growing. If it's denuded like that, we get a lot of rain, we have erosion. The animals also like to tear it up a little bit, whether it's over just traffic or if they're digging for salts or something. They end up having little holes where it needs to be repaired before we go into winter, and to reseed some of those bare areas. Moles are another big problem again. They start at the top, or they start at the bottom and work their way up, and pretty soon this lagoon, even though it's a foot down, it's going to wick right straight through that and come out over here somewhere, and you won't even see water up here, but there'll be water coming out the lagoon dike at the toe, and not understanding where that's coming from, except there's millions of holes up there. What do you do? And at this time of year, when it's full, it's a tough time to do anything. So bringing that level back down, it'll usually stop leaking, and then you know it's just a mole hole, but that means you're going to have to get in there to maintain those. And rodents, skunks, seen the possums, and other things making very big nests in the side of a lagoon with some leakage in them, and so trying to control those animals as best you can. In the lagoon bank, where this lagoon was filled all the way to the top, and all of a sudden you get a runoff out the side. Solids management, again, having this all the way to the top, it wasn't running over because they placed some fill material, but it was actually wicking out the side. Even the best maintained lagoons can have problems. We had an irrigation pond blew out 2 summers ago. Interior dike maintenance. So the interior dike kind of gets ignored a lot of times on the double lagoon, and the standard is that that dike should be above the outside dike levels, and that splits that lagoon apart so that there's 2 separate lagoons. And oftentimes this is an issue with dam safety rules. If you're over 10 acre-feet, you need to get a dam safety permit, and that becomes costly, and there's other maintenance things that come along with it. And dam safety, they require a spillway, and this spillway should be 1 foot above the top of the dike, and then the actual freeboard is a foot below that. So again, having that spillway, you lose a foot, so you actually have 2 feet of freeboard, and then operating at a lower level. Dam safety requires you to do a wind and wave action assessment to make sure that the waves aren't going to go over the top of the lagoon bank. Again, this is not an extreme weather event, but a full lagoon in some wind. And if there was a ditch down here, this would be an issue to maintain this lagoon at a lower level. Construction site preparation, when we started to go into some of these newer lagoon sites, we're putting a new lagoon where it used to be a field, and there's field tile out there. The requirement from NRCS now is to go through and remove those tiles out in the field, and it's a challenge to find all those tiles, especially with new operators, or just some of this tile went in 30 years ago, so trying to find all that tile out there to get it out before you start or before you place a lagoon. Building a lagoon, there were site conditions that we want to look at. The seasonal high water table determination. This is Chuck Natsahara, soils scientist for NRCS, looking at the type of soil, water table depth. There's actually water in the bottom here. And determining the seasonal high water table, it's where the water comes up to for an extended period of time during the growing season or during the year. And it colors the soil, and so that mark is actually where the bottom of the pond has to be 2 feet above. So a lot of our soils, we do have those indicators up near the surface, so by being 2 feet above that, the bottom of the pond oftentimes is at the surface of the field, and that limits how much storage we can get out of a pond. So as to maintaining your existing storage structures is critical, because if you have to take that and go to the new standard, you're going to go from maybe a pond that was down into the water table that was legally built and to the standard. Now you have to raise it up here 2 feet above, and you just lost 4 feet of storage. And that's just because the standard has changed over the years. And that's going to be a big impact on your storage on your farm. The NRCS position on lagoons right now is that as long as you can maintain them with minimal disturbance, you can go back in and maintain those. And so maintaining those existing structures is very important. If it's identified by Department of Agriculture as a leaking lagoon or a problem in having to rebuild, that is a very large expense. The design depth again, then whether the actual material is suitable for a liner. If the clay material needs to meet certain parameters for quality, for permeability, so the water doesn't go through when you put manure in. And a lot of our soils that may have met the old standard are not meeting the new standard with the permeability test. It has to meet a very small window of how fast the water will drain through it, and they put it in the laboratory in a, they call it falling head test, where the water goes down through a pipe, and it's how fast or how much water makes out the bottom of that pipe to determine whether the existing clay on the site is meets the spec. Or we've got a few borrow sites or gravel pits that do have material, and actually some farmers who've built lagoons that have material available as well. The quantities of that material in different locations around the county it's harder to find at certain times of the year or with reduced construction, so we've got a difficult time finding clay or trucking clay and making it a reasonable cost. The cost of trucking clay may be more than buying it from a gravel pit. This is a liner example of a failure. With this pond had the outside, so this dike had just been built, or the lagoon had been built, and they had a flood that pushed the bottom of the lagoon out before the water before that could be sealed by manure. The idea is that you wouldn't have water on the outside pushing up. if you've built this above the season high water table, is the reason for that change in the standard. This is in a flood condition, and these are, again, just water pushing up. The quantity, again, is a large quantity for that liner material, not just, it's 1 foot thick, but it takes compaction to get there, so it's a very large amount of clay that needs to be put in. Spillway and ramps, the erosion areas where water goes into a pond, the agitators seem like they have done a lot of damage on the older ponds where they were put in just straight down the ramp, and it's burrowed a hole in the bottom and sent sediment out into the middle of the pond. This is a cross section talking about the overflow pipe and having a collection and an outlet for that. There's different designs on that. Maintenance is still something that's critical because of the solids buildup on this edge and weeds. This overflow or inlet would have a hard time getting material into it to get across there. So maintenance is critical on those. The outlet flowing back into the pond, if you see a ramp that's higher than the lagoon bank, it's usually an indication of erosion. And these are the kind of things that the agricultural inspectors are looking for. This would be a concern that this is no longer meeting standard, and they need to get this patched up and filled in with some clay. We use concrete underneath those. You can use broken concrete or poured in place concrete. The agi pumps have been a real benefit for agitation instead of the prop agitators, just because of the erosion in the bottom of the pond. We still have a propeller usually on the bottom of that can do some damage, so making sure that that's not happening. But the length of time that they're trying to turn it with a prop, it seems like these types have been very successful. Dry storage roof, it not only keeps it covers in this case, this was Galen's farm, and they did manure recovery for bedding, but it also reduces the amount of manure storage that you need because of the rain falling on the manure. There's a synthetic or coverall type. Ecology blocks are sometimes used for wall. The minimum requirement is to have no more than 2 above the dirt behind it, so backfill up to the first one on this case. We've used tilt-up walls. Some of the sand recovery projects we've worked on, there's still a fair amount of manure solids that come off of them as well. So there's sand and manure solids that come off of them, and to have a covered dry stack to help with composting as well. Without the roof over the top, there's a large surface area that needs to be collected. So if we're just looking at the overall storage of your farm, putting in a design or putting in a separator, may not actually reduce the total storage that you need. So the separator by itself, we figured in a sawdust system is removing 0.6 of a cubic foot per day per cow. And if you multiply that out by the storage period, you can reduce the amount that goes into the lagoon. But if you have this large surface area that's actually collecting water, you can be putting more back in it than you're actually removing from the solids volume. Our designs within our CS is thick walls for tall walls, and this would be a 10-inch wall and 12-inch rebar spacing for, I believe this was an 8-foot wall. The height of that wall, we have to design around liquid storage standard. Dry stacks and silage bunkers, the placement of those has been a problem with leaching out the bottom, and this is where a tile was found and indicated to be collecting fecal coliform and getting into a ditch. The silage bunkers usually have cracks in the bottom of them, so whether it was silage or manure, it wouldn't have mattered, but having a tile right directly underneath the concrete floor was the issue. This is an extreme case, but again, what we're looking for is vegetation or managed vegetation. Solids buildup is an issue. When you look close here, there's erosion off the top where the had overtopped. And then actually in this road here, there's cracks in the road. And that crack is from that clay or that structure drying during the summertime. That material that had been pushed around a bit had been mixed with manure and vegetation to repatch a hole in the side of the lagoon. The amount of solids on this one was extreme, but it was a 17-foot deep lagoon that had a D6 cat crawling across the top of the solids on the top of it, even though there was liquid underneath it. So that was the clay in that lagoon. That's a 3-foot piece of lath that I pushed in without even effort, just like butter right straight through. So the amount of saturation in this wall and trying to, you know, keeping the water off of the top of the lagoon. Doing more concrete pits, and one of the things is having an entrance or an escape way. If someone does get trapped in this, they're going to have to either crawl up that pump. In this case, they have a ramp to crawl out the back, but it is an issue that for safety for the gases and just hypothermia during the winter time. When you think about this is water stop, and in that concrete wall at the bottom where we do cold joints with the concrete construction, we're putting in that to keep the water out, the groundwater out, as well as keeping the manure from escaping or leaking. And this is Mr. Bill Bonson here. Again, a ramp, but thinking about where safety, but also water. Can you get water in here for a flood? And trying to keep it protected from just the driveway water running into it. For storage volume, you know, this tank should have a berm out there to keep the water moving away from it. Fence around the outside for safety. The steel concrete tanks, we've worked with Dairy Tech's installed a few of them with us, and or with the farmers, and with it's been one way to get a lot of storage out of a smaller footprint and with less rainwater collected. This is an example of a storage pond, that same one that we were talking about for 400 cows. You could get out to 5 months of storage. So this is 3 million gallons of net storage. But to get 1 more month, it looks like all you need to do is add another 500,000 gallons of storage. But to get there, you actually have to add a whole nother lagoon that has 1.6 million gallons. Because of the footprint of that lagoon, you have to collect all the rainwater that's going to fall on that, and that gets you 1 more month at 4.7, 200 by 200, so it's a little smaller pond. But with today's standard, you got to come up to that foot, or I used a foot in this case to show that those new lagoons are a lot less volume of manure storage than the existing ones that you have on your farm. That one's small. I did a calculation on that storage volume, so the total gallons for that's different is 1.6 million. That's this number. But the additional rainwater that you collect compared to the other one was 1.1 million. That's without any manure. That's just the rainwater that's going to fall in that new lagoon. To get that 1 extra month, you have to pump 1 million gallons in the year for that lagoon. The same tank, to get the same amount of storage, you'd be pumping an additional 70,000 gallons, but that gets you that month of storage for that same cow number. And then covering that lagoon, if you cover that original 250 by 220, it's going to be about 1.5 million gallons less that you have to pump to get the same amount of storage. So those are some options to think about when you're looking at manure storage. I hope everyone's done chewing their pizza, because that's the end of it.